Okay, so the first thing that the question asks you is how long the bullet was in contact with the wooden block. So, in order to find that, I have to use the equation F net equals change in momentum over change in time, and to solve for and I know we have to solve for change in time. So to solve for change in time, I know we have to find F net. So I drew my free body diagram, and I labeled all the forces acting on the body, and it has the normal force going straight up and mg going straight down, and then the frictional force going in that direction to the left, and then this force of the bullet coming out of the box going 180 meters per second. So I resolved this force into two components, into 180 cosine 10 for the x component and 180 sine 10 for y. And the only force acting against the block going in the opposite direction is the frictional force. So I had to find the frictional force, and they tell you that the wooden block has a force of 40 newtons. So to find the frictional force, I did 40 newtons times 0.2, which is the coefficient, the static coefficient. The friction coefficient. And so you get that the frictional force is 8 newtons. So then I used my formula. The net force of the bullet is the change in momentum over the change in time, which is mass times final velocity minus mass times initial velocity over the change in time. And so I know the mass of the bullet, which is 0.3, and then the final velocity is, since it's in the x direction, we use 180 cosine 10, and then you subtract the mass and the initial velocity. And I set it equal to -8 because the frictional force is going in the opposite direction of the body that's moving, because it's moving with the bullet going the other way. So you have to make it negative. So I solved for the change in time, and I got that the change in time was 15.85 seconds. And then for part B, they ask you to find the speed of the block when it's moving, when the bullet hits it. So I knew that we have to use the same formula. The net force of the box equals the change in momentum over the change in time. And this time we know the change in time, so we can so we still have to find the force of the box again, and we have to find, we're looking for V2F. So in order to find that, I filled in all my variables with my values, and I set it equal to 8, for 8 being the force, because the only force acting on the box is the frictional force going in the negative direction. But in order for the box to move, it needs at least 8 newtons to act on it. So you have to set it equal to 8, because the force the bullet must exert on the box to move is equal and opposite to the frictional force. So I said equal to 8, and then I plugged in all my values, and I solved for the final velocity, and I got 31 meters per second. And then part C, they ask you to find the distance moved by the box, and you use this equation, d equals x1 plus vi times t plus 1/2 times acceleration times t squared. And we know everything for this equation except for the acceleration. So then I have to find the acceleration in order to find the distance. So to find acceleration, I use this formula: velocity final equals initial velocity plus acceleration times time. And I use this because I have initial velocity, I have time, and I have final velocity, because we know that the body comes to rest, so it's 0 for the final velocity. So I plugged in all my values: initial velocity 31 and time 15.85, and I solved for A and got that A equals -1.96 meters per second squared. And then so now that I have A, I can finally solve for the distance moved by the box. So I put in all my values for everything. 31 for initial velocity, 15.85 for time, negative 1.96 for acceleration, and 15.85 for time again. So, and once I calculated all this together, I got that the distance moved by the block was 245 meters.